Alright, so today we are going to be talking a little bit about scientific notation. You might have done this in your math class. If so, no worries, it'll be a review. If not, I know you'll be able to get it. Okay, so basically what scientific notation is, it's a way to express a number. Any number, really big numbers, really small numbers, just way to express them easier. So we express them between the number 1 and the number 10, and we use powers of 10 to help us. Okay, so an example of something that is scientific notation would be 6.04 times 10 to the 2. Okay, and what that stands for is 604. Okay, this is your scientific notation, and this is your standard notation. Right? So it's just an easy way of representing really large numbers and really small numbers, okay? So a positive exponent, like the one I did here, means that it's going to be a large number, okay? It's going to be greater than 0. A negative exponent means that it's going to be a small number, smaller than 1, sorry. Positive exponent, greater than 1, negative exponent, between 0 and 1, all right? Excellent. All right, so our first example that we're going to do is going to be converting standard to scientific notation. So the first thing that I want you to do is I want you to find your decimal point, which is going to be right here. Mark that in. And then what you're going to do is you're going to take your decimal point and you're going to move it over. And your end point is going to be between your first two numbers. Okay? So I'm going to go 1, 2, 3, 4, 5. Then I'm going to rewrite this number. It's going to be 5 point, so that's where my decimal point is, 25 times 10 to the 5th, because there are 1, 2, 3, 4, 5 places we moved it over. We use 5.25. Okay, we're always going to put it between the first and second number. So you're going to have a number between 1 and 10, and then your decimal places, and then how many places over you moved, okay? This is going to be your power, all right? Let's try our second one. So we're going to put our same thing, put our finger on our decimal point. We're going to move it over. 1, 2, 3. We're going to stop there between our first two real digits that are not 0. So we've got 3.4 times 10 to the, oh, and I forgot it, so it's 1, 2, 3. But this time it's not going to be just 3. It's going to be negative 3 because this is a small number, okay? This is going to be a small number because it's negative. And here, this is a big number, so it's going to be positive. All right? So you guys see the difference between the negative sign and the positive sign in those exponents. I'm going to give you guys a chance to do this practice next. All right, so what I want you guys to do is I want you to write down practice problem number 1, and I want you to try both of these. Please make sure you're doing your looping. All right, move those decimal places over and always go between the first two numbers that are not 0. Okay, so sometimes I like to make a box around them, all right, just when you get the hang of it, okay? So put your decimal point between the first two numbers that are not 0. Okay, give these ones a try. All right, let's try another example. This time we're going to go from scientific notation. So we're going to start with the scientific notation and we're going to convert it to standard notation, which is what you guys are more comfortable seeing. So this time we have to interpret these exponents. So here I'm seeing a positive 4. So that means I'm going to move my decimal point so this becomes a bigger number. So I'm going to move it to the right. I'm going to go 4 places. 1, 2, 3, 4. Okay, so I write it. I'll write it again, 3.2, and moving it over. 1, 2, 3, 4, and then that's my decimal point. In each of the loops, you're going to put a 0. Okay, so that turns into 32,000 as my answer. All right, let's try our next one. This time we've got a negative exponent, okay? So for that negative exponent, you're going to move your decimal place to the left. So here, I'll start it out, and I'm going to move it over 2. 1, 2. Put my decimal point. I'm going to fill in my 0. I'm also going to put a 0 here on the other side of the decimal point just as a placeholder. So I'm going to have 0.045. Whenever we write decimals, we want to have that placeholder 0. Otherwise, it looks like this. right? And sometimes if their decimal isn't big enough, we can't tell that it's a real decimal, so we always put that 0 in there, all right? So that is going to be our answer for our standard notation, all right? I want you to write practice number 2, and I want you to try these two. This one's going to be a positive exponent, and this one is your negative exponent, so try one of each. All right, so the last part about scientific notation is that sometimes we talk about things in different language in chemistry. So we've got some prefixes. You probably have heard of these before. A centimeter, right? A millimeter. So we use these prefixes here, K, D, C, to represent those prefixes. Okay, so a milli is M, so a millimeter would be this. Millimeter. Okay, a centimeter, you guys are used to measuring with. Right? And in chemistry, we have to use really small particles, so sometimes we're going to use a nanometer, okay, which is going to be -9, or a picometer, pm, which is 10 to the -12. Okay, so these are all the scientific notations for each of these prefixes and their symbol, right? So I want you to write this down in a chart as well. You will need to know these. You will need to reference these. All right, have a good one.